So, good day everyone. I'm going to explain to you what is ellipse and its properties. First, what is ellipse? Ellipse is a set of all points in a plane such that the sum of distance called foci is constant. Foci are two fixed points in a plane, also known as P. This is F2 and F1. And the distance between foci is called focal length, or also known as 2c. Vertices are the turning point of an ellipse, and also known as A. And the length for the major axis is 2a. The endpoints of minor axis is denoted by B. This is B sub 2 and B sub 1. And the length of minor axis is called 2b. By definition of an ellipse, d1 plus d2 is constant for any point x, y on the ellipse. We know that the sum of this distance is 2a for the vertex. It follows that d1 plus d2 equals 2a for any point on the ellipse. We will begin the derivation by applying the distance formula. The rest of the derivation is algebraic. The formula for the distance formula is square root of x2 and x1 minus y2 and y1. This is the formula for the distance formula. And by the definition of an ellipse, d1 plus d2 is constant from any point xy. So the d1 is negative c equals to 0, and d2 is equals to positive c equals to 0, and the point is called xy. Formula for the standard equation of an ellipse is this: the absolute value of d1 plus d2 is equals to 2a, or f1 and point plus f2 and its point is equals to 2a, and absolute value for this. Applying the distance formula is x minus negative c squared plus y minus 0 squared plus another distance formula, x minus c squared plus y minus 0 squared is equals to 2a. Negative times negative is equals to x plus c squared plus y squared plus another distance formula, x minus c squared plus y squared is equals to 2a. Simplify the expressions: x plus c squared plus y squared. You move the another distance formula to the 2a, or it is called transposition. Transpose the another distance formula to the c. So 2a minus square root of x minus c squared plus y squared. After you move the radical to opposite side, square both sides. The square root will cancel. X plus c squared plus y squared equals to 4a squared plus 4a square root of x minus c squared plus y squared, and another x minus c squared plus y squared. After squaring both sides, you expand the square. So you will use exponent. X times x is x squared, and x plus c is cx, x times c, cx, and c times c is 6 squared, and plus y2, 4a squared plus 4a x minus c squared plus y squared plus expand the square again, x squared plus cx plus cx plus c squared plus y2. After expanding the squares, expand the remaining squares. So, x squared plus 2cx plus c squared plus y2. After cancelling the squares, so the remaining is 2cx equals to 4a squared plus 4a and the square root of x minus c squared plus y squared minus 2cx. By combining like terms, so the negative 2cx will transpose at this. So 4cx is minus 4a squared. Transpose it and equals to 4a and the square root of x minus c squared plus y squared. And you will divide it by 4. So 4. So the remaining cx minus a squared equals to a the square root of x minus squared plus y squared. After it, simplifying the expression and expand the squares. So c squared and x squared. So negative a squared cx minus negative a squared cs is 2a squared and cx plus a4. So equals to a squared. Expand the remaining square. So x squared minus cx minus cx plus c squared equals to y2. That distribute the a squared. So a squared times x squared is a squared equals x squared, and a squared times negative 2cx is equals to negative 2 a squared cx, and a squared times c squared is equals to a squared c squared, and a squared times y squared is equals to a squared and y squared. Remember, the Pythagorean theorem is b squared equals to a squared minus c squared. So you will change the a squared minus c squared into b squared. So x squared b squared plus a squared and y squared equals to a squared b squared. And this, divide it to a squared b squared, a squared b squared, cancel out. So x squared is equals to a squared plus y squared equals to b squared equals to 1 is the standard equation of an ellipse. Now you've successfully derived the formula for the standard equation of an ellipse. So now I'm going to give you some examples to prove that this equation is for the ellipse. So the given is 4x squared over 36 plus 9y squared over 36 equals to 36. Now all divided by 4. So 36 divided by 4 is equals 9 plus 36 divided by 9 is equals to 4. So 36 divided by 36 is equals to 1. So this is the sample equation for the standard equation. So now we will find its properties. So the center is 0 because the standard equation is centered at origin. To find the coordinates, so the vertices. Vertices is the turning point of an ellipse. So to find the vertices, you always know what the major axis is. The major axis is always has the large number. So a squared is equals to 9. The square root of 9 is 3. So a equals to 3. And b squared, the minor axis. So b squared equals to 4. The square root of 4 is 2. So to find the c squared, you need to subtract the a squared to b squared. So c squared is equals to square root of 9 minus 4. C squared is equals to 5. Square root of 5 and square root of c squared. C is equals to 2.24. Your C or the foci is 24. So to find out the vertices, you have a 3. So 3 and 0, negative 3 and 0. This is the ordered pairs for the vertices. So the foci. Foci is the distance to the point from the center. So 2.24 and 0 and negative 2.0. So the endpoints of minor axis is b squared. B. So 0 and 2. Then 0 and negative 2. We will find the length of the major axis. So length of major axis is 2a. So 2 times 3 is 6. Length of minor axis is 2b. So 2 times 2 is equals to 4. And length of the foci is 2c. So 2 times 2.24 equals to 4.48. So now we will proceed to the plotting of the coordinates. So first, draw a Cartesian plane. So for the vertices is 3 and 0. And the other vertices is negative 3 and 0. So the foci is 2.24 and 2.24. So the endpoints of minor axis is 0 and 2. 0 and 2. So form the oval shape. So now, this is the ellipse. So, the important relation on ellipse, let the distance from the center to the vertex be A. The distance from the center to focus is C. And the distance from the center to the directrix as D. So, to find D, the formula for the directrix is D equals to A over E. So, D equals to major axis divided by eccentricity. So, to find the eccentricity, you need to minus A minus C over directrix minus A. Eccentricity, the ratio between the distance of any point from a given fixed point, the focus, and its distance from a given fixed line directrix. So, to find the eccentricity, you need to derive some formula to find the eccentricity without knowing the other properties. So, C equals to AE. Divide it by A. So, A. So, cancel it, the A. So, E is equal to C over A. So, eccentricity. So, E equals to 2.24. 2.24 is your foci and divide 3. So, remember, note, the eccentricity of an ellipse is always lower than 1. So, 2.24 divided by 3 is equal to 0.75. So, now to find the directrix. D is equals to A over E. So, your A is 3 divided by 0.75. So, D is equals to 4. So, the directrix is 4. So, the directrix is always 2. So, the directrix is this. 4. So, now, to make sure that your ellipse is correct, you need to find the formula for the latus rectum. So, your latus rectum always has 4. So, in the ellipse, you need to find the 4 plot points to form the ellipse, to make sure that your ellipse or the shape is right. So, C is equals to B squared over A. So, your coordinates for the latus rectum is C over B squared over A. So, this coordinates for the latus rectum is 4. Like in the Cartesian plane, it also has 4 quadrants. So, C and B squared over A, C, negative C, B squared over A, negative C, and negative B squared over A, and C, and negative B squared over A. But before that, we need to find the latus rectum. So, the latus rectum formula is 2B squared over A is equals to 2 times 4 divided by 3. 8 divided by 3. So, 8 divided by 3 is equals to 2.67. So, your latus rectum is 2.67. So, to find the coordinates of the latus rectum, you need to follow this formula. So, each quadrant has having each formula. So, first, C is B squared over A. So, your C is foci 2.24 and B squared 4 divided by 3. So, 2.24 and 4 divided by 3 is 1.33. So, 2.24, 1.33. You need to plot this. So, 2.24 and 1.33. It also applies. So, you don't need to solve all for that, because if you find the solving of the each formula, you also need to put the negative sign or the positive sign, so you can easily to plot the points. So, like for that, so negative C and B squared over A, you put the negative to 2.24. So, 2.24 and 1.33 is like that. And for that negative C and negative B squared over A, so you only need to put the negative sign on it. So, this. So, for the last for the quadrant 4, or the last formula for the length of not length but the coordinates of the latus rectum is positive c and negative b squared over a. So the positive 2.24 and negative 1.33. So this is the coordinates of your latus rectum. Ellipse. The standard equation of an ellipse were centered at origin. This is the properties of an ellipse that shows you how to form the right ellipse, how to form the right shape for an ellipse by plotting the points. So the standard equation of an ellipse where it lies at h and k is x minus h squared over a squared plus y minus k squared over b squared is equals to 1. The other standard form of an ellipse, the center is h and k. So using the translation of axis, we obtain the standard equation. So determining the coordinates for it. So center, your center now is at h and k, so it doesn't have to be 0. So 2, negative 2, and 1 for positive 1. Now we will need to find its coordinates. So for the vertices, a plus h and k. For the second is negative a plus h and k. For the foci is c plus h and k, then negative c plus h and k. The formula for the endpoints of minor axis is h b plus k and h and negative b plus k. So we need now to find the a, b, and c. So a squared is equals to 16 and b squared is equals to 9. So the square root of 16 is 4, a equals to 4, and the square root of 9 is 3. So b is equals to 3. So c squared is equals to square root of a squared minus b squared. So c squared is equals to square root of 16 minus 9. C squared is equals to 7. So square root 8. So c equals to 2.65. So now we will substitute it. So for the vertices is equals to 2 and 1 and negative 6 and 1, and the foci is 0.65 and 1, then negative 4.65 and 1, and where the endpoints of minor axis is negative 2 and 4, then negative 2 and negative 2. So we will move on to the finding of eccentricity. So E is equals to 2.65 divided by 4. So your E is equals to 0.6. Going to find the directrices. So D is equals to A over E. D is equals to 4 divided by 0.266 is D is equals to 6.06. So now we will move on to the finding of to determine what the length of latus rectum is. So equals to 2b squared over a. So 2 times 9 over 4, 18 divided by 4. So R is equals to 18 divided by 4 is 4.5. So now we will proceed to the endpoints of lateral recta. c plus h and b squared over a plus k, then negative c plus h and b squared over a plus k, then negative c plus h and negative b squared over a plus k, and c plus h and negative b squared over a plus k. So for your coordinate number 1, your c is 2.65 and your h is negative 2, then your b squared is 9 and your a is 4 plus your k is 1. So 2.65 minus 2 is 0.65. Then 9 divided by 4 is 2.25 plus 1, 0.65 and 3.25. That is for your lateral recta number 1. And for the lateral recta number 2 or coordinate number 2, negative 2.65 and minus 2 and 9 over 4 plus 1. So negative 2.65 minus 2 is 4.65. Then 9 divided by 4 is 2.25 plus 1 is negative 4.65 and positive 3.25. So for the coordinate number 3, so negative 2.65 minus 2 and negative 9 over 4 plus 1. So negative 2.65 minus 2 is negative 4.65. Then negative 9 divided by 4 is negative 2.25 plus 1. So negative 4.65 and negative 1.25. And for the last and the coordinate number 4, so your c is 2.65 plus negative times and plus negative 2 and negative 9 over 4 plus 1. So 2.65 minus 2 and negative 9 divided by 4 is negative 2.25 plus 1. So 2.65 minus 2 is 0.65, then negative 1.25. So those are the lateral rectas for the ellipse. So now we will draw the Cartesian plane. So your center now is at H and K. So your center is negative 2 and 1. For your vertices, the first vertices is 2 and 1. Then the second is negative 6 and 1. For your foci is 0.65 and 1 and negative 4.65 and 1. And for your bisector or the endpoints of minor axis is negative 2 over 4 and negative 2 and negative 2. So the formula for your general equation of an ellipse is ax squared plus cy squared plus dx plus ey plus x equals to 0. So now, we will use the standard equation to derive the formula to get the general equation of an ellipse. So, x minus h squared over a squared plus y minus k squared plus over b squared over 1. So, you cross multiply this one. So, b squared or x minus h squared plus a squared and y minus k squared over 1. Because of 1, we will use the a squared b squared, because a squared b squared divided by a squared and b squared is also 1. So, we will use it as a squared and b squared. So, you expand the remaining squares. B squares. Then, combine like terms. Distribute the a squared and b squared. So, after you distributed it properly, rearrange the term. So, b squared, x squared. You transpose the a squared b squared. So, okay, b squared is equals to 0. So, after you arrange the similar like terms, so, let this coefficient, so, let this b squared be your a, and let your a squared be your c, and let your negative 2b squared h be your d, and let your negative 2a squared k be your e, and let your b squared h squared plus a squared k squared and minus a squared b squared be your f as constant. Equate it to 0. You preserve the sign, and this is the general equation of an ellipse.